Hi, in this video we're going to continue doing some examples of a derivative with inverse trigonometric functions. So it would be nice if we can combine some of these examples with other rules, like not only the chain rule but the power rule, and also the product rule, the quotient rule, and so on. So first let's do an example with the product rule. So if we have y equals 2x sine to the minus 1 of x cubed, then y prime is going to be a product rule. So we're going to have the derivative of 2x times sine to the minus 1 to x cubed plus then 2x in the derivative of sine to the minus 1 x cubed. Notice that the only thing that I did here was stating the derivatives. Now let's actually compute them. The derivative of 2x is 2, so 2 sine to the minus 1 x cubed plus, and then here to x. And now we're actually going to go for the derivative of sine to the minus 1, which is 1 over the root of 1 minus x squared regularly, but here we have x cubed, so we have to compose with x cubed. X cubed composes square, and now by chain rule here, this is going to be 3x squared. A little bit of simplification is going to have you ours, but that's pretty much all that you can do in here. So we're going to get 6x to the 3 over 1 minus x to the 6. And so that'll be the end for number 1. Now let's go to number 2. Number 2, we're going with a chain rule. Y is equals tangent to the minus 1 of 3x minus 4. So that implies that y prime is just going to be 1 over 1 plus whatever is inside the square. So 3x minus 4 is square times the derivative of 3x minus 4, which is going to be 3. Okay, there's not a lot of simplification that you can do in there. You can just, if you want to leave the 3 in there, and that's going to give you this. But otherwise, there's not a lot more in there. Now let's see what happens with 3, which is cosecant to the minus 1 of x to the 5 plus 1. Now notice that in this case, we're going to use the rule for cosecant. The rule for cosecant is very similar to the rule for secant. So remember, the only change is that it's going to have a minus now. And the absolute value is going to have the function that is here. So x to the 5 plus 1. And then we're going to have a root of the function that is here inside the square. So x to the 5 plus 1 is square minus 1. And at this point, of course, we just did the derivative of cosecant to the minus 1. So we need to multiply by the chain rule. So we need to multiply by the derivative of the inside function, which is x to the 5 plus 1. So we take the derivative of that, we're going to get 5x to the 4. The derivative of 1 is here, and that's it. So we simplify this, we get minus 5x to the 4 divided the absolute value of x to the 5 plus 1 times the square root of x to the 5 plus 1 is square minus 1. Okay, and that's all for this first first set of 3 examples. Now let's see what happens if we take a couple of things. First, we're going to see a power. And then we're going to see what happens if we take the cotangent, which is one that we are yet to do an example. So with the power, the situation is going to be very similar as the usual. F prime of t is going to be focused first on the power. So the derivative of the power is put down the exponent. I'll leave the function inside as it is and subtract 1 from the exponent. So 7 cosine to the minus 1 of t power to the 6, and then multiply by the chain rule. And at this point is where the inverse trigonometric function kicks in, this is cosine to the minus 1, so we got that this is minus 1 over the square root of 1 minus t squared. Notice that you always have to put the square with the variable that we have. In this case, we have variable t, so that's why it's t squared in here. Okay. Again, this can be simplified a bit, not a lot. So we get minus 7 cosine to the minus 1 of t power to the 6 over 1 minus t squared. And that's for number 4. Now for number 5, we're doing the cotangent. Okay, and it's important to remember that cotangent has a very similar behavior to tangent. So if we're taking 7 cotangent to the minus 1 of e to the 3x, this is going to have that 7 multiplied by 1 minus 1 because it's cotangent, 1 plus, and so whatever the function is inside a square. So in this case is e to the 3x. So e to the 3x is square, and then we multiply by the chain rule, which is the derivative of e to the 3x. So e to the 3x times 3. Okay. So notice that the most important and different things from the cotangent to the tangent is the fact that we have this minus in here. That's all the variation that is producing. Now we multiply the numbers and simplify a little bit. So this is going to be minus 21 e to the 3x over 1 plus e to the 6x if needed. Okay, or you can just leave it e to the 3x squared. Now to finalize the examples for this section, we have these two functions. So f of c is going to be 2 tangent to the minus 1 of the square root of 6c. So this is a usual chain rule. So when we calculate f prime of c, we're going to go for all cases. This is twice, and the derivative of tangent is 1 plus 1 over whatever it is square. And it turns out that this function here is a square root of 6c, so that's what we plug inside. And then we have to multiply by the chain rule of that. And what is the chain rule of that? Well, that's going to be 1 over twice a square root of 6c times the derivative of the function inside, which is 6c, so it's going to be a 6. So this is the full chain rule in there. Of course, we can simplify this a little bit. Notice that this 2 goes away with this 2, and so we're going to be left with that c with this 6. So we get 6 on top, and so on the bottom we get square root of 6c times 1 plus, and then we get rid of the square root of here, 6c, and everything and everything is complete here. All right. Now sometimes you're going to have things like the product rule or the quotient rule inside of the inverse trigonometric function. And the way that that's going to affect everything is that that's going to appear in your chain rule. So that's the example here for g. So g of x is cosine to the minus 1 of e to the 2x times square root of x. So in this case, because we have cosine to the minus 1, we have minus 1 over the square root of 1 minus whatever is inside x squared. Normally it's x, so x squared. In this case, we have e to the 2x, the square root of x. So that's what goes inside. And now here we gotta multiply by the chain rule. But the chain rule in this scenario is going to be a product rule. It's going to be the derivative of e to the 2x, which is 2e to the 2x times the square root of x, plus e to the 2x without derivative times 1 over 2 square root of x, which is the derivative of the root. Okay. Now simplifying here is going to be a little bit more cumbersome. You can still try and do some of the pieces at least. So for example, you can simplify what the bottom is going to look like. And so that's going to be 1 minus e to the 4x x. The square root of x squared is x, and e to the 2x squared is e to the 4x. Okay, and now with that, you can just multiply what this is in here, and so we're getting 2e to the 2x, the square root of x, with a minus, and minus e to the 2x over 2 square root of x. Notice that this square root of x can be a little bothersome here, so we can actually get rid of that if we multiply by square root of x top and bottom, but that's a little bit more algebra that goes beyond the scope of the derivative. Okay, so we can just leave it like that if you prefer, or at this point, yeah, just let's multiply top and bottom by 2 square root of x. And so now the bottom line is 2 square root of x times 1 minus x e to the 4x. And now why am I multiplying by 2 square root of x? Because notice that this becomes minus 4x e to the 2x, this first part. And now this transform in e to the 2x. And that's it. So this is the simplified version of that. All right, this is the end of the examples for derivatives of inverse trigonometric functions.